Start the Jupyter notebook and open the PDF file shared in your WhatsApp group. From the PDF file, copy this bunch line of code. हाँ हाँ हाँ, कहीं पे भी डाउनलोड कर सकते हो। एक ही है, वन PDF है। Sir, you do not need to write anything. Just open the PDF and you can directly copy paste. This one you can copy. Yeah, yeah. Copy and paste and run. मॉड्यूल ही नहीं है आपके पास। रन हुआ सर? ओके, ठीक है, चलने दीजिए। कनेक्शन फेल्ड। ये गूगल, ये जो आपने खोला है जुपिटर नोटबुक, उसका वो कहाँ है? कंपाइलर, कमांड प्रॉम्प्ट कहाँ है उसकी? हुआ टेंसरफ्लो? हाँ, हो रहा है। ठीक है। If there is error, no module name TensorFlow, write down pip space install space TensorFlow. Pip install TensorFlow. एरर आ रही है? Run it. Oh. स्पेलिंग सही है? टाइम आउट आ रहा है कुछ। टाइम आउट आ रहा है। सबका सेम आ रहा है। आपका भी सेम आ रहा है। कंट्रोल भी इनको भी सेम बताइए। वैसे अच्छा आप ऐसे कर
मैम बट द थिंग इज कि ये तो मशीन में इंस्टॉल होगा ना, एंड वी आर ऑपरेटिंग ऑन द जुपिटर नोटबुक इन ऑनलाइन मोड।
ऑनलाइन मोड पे कहाँ हो आप?
No, this is online. We are operating on the online Jupyter, na? Online Jupyter platform, na?
अच्छा आप ऑनलाइन ही यूज कर रहे हो।
If we are installing it, this will be installed in the machine.
एनाकोंडा से नहीं है इसमें। Browser is only the application interface connected to the Anaconda. This is connected to Anaconda only. So you can open the Anaconda prompt and manually you can install. Otherwise, this one is also. Install TensorFlow invalid syntax. Control V. ये कहाँ है? यहाँ पे आप कर रहे हो ना?
This is through terminal, but this will get installed in the machine, na?
हाँ देखते हैं, नहीं तो उसका पाथ सेट करेंगे।
Okay.
जुपिटर नोटबुक आपने स्टार्ट कैसे किया है?
Online is on the in the Google Chrome. Google Chrome itself.
अच्छा तो ये आपका गूगल वाला है। हाँ तब वो काम नहीं करेगा।
Yes, that is what I am saying, because this will get installed in the standalone machine, na? And we are operating in an online platform. That is the problem.
You can change the system.
I can do.
You can share the system. हो रहा है सबका? Good. Sorry. डीप लर्निंग नहीं डीप लर्निंग के सेशन हुए ना इसके पहले। फिर टेंसरफ्लो वहाँ पे जरूरत नहीं पड़ा।
उन्होंने सिंपल हार्ड ड्राइव डिटेक्शन का मॉडल भी दिया था, तो उन्होंने टेंसरफ्लो या केरास यूज किया।
ये तो बहुत टाइम ले रहा है।
ये ओलैप पे भी इंस्टॉल कर सकते हैं।
हाँ। एक मिनट क्या था, ये तो कोलैब का डायरेक्टरी शेयर कर देती हूँ मैं। Copy. ये शेयर करने के लिए ईमेल आईडी नहीं नहीं, ये मेरा ड्राइव का लिंक है एक्चुअली, तो मैं किसको करूं? नंदनी। कॉपी लिंक, मैनेज एक्सेस, व्यू, एडिटर। हाँ, बस एक्सेस चेंज कर रही हूँ एक्चुअली। वेन आईटी से है ना, तो वो रिस्ट्रिक्शन बहुत देता है। कॉपी, सेंड टू डिवाइस। व्हाट्सएप में किसको शेयर करना है? नंदिनी मैम को कर दो। हाँ, कर दिया। हाँ, क्या हुआ?
हाँ मैट्रिक शो हो रही थी,
हम्म।
तो मैंने गूगल खोला, इसको रन किया तो उसको इतना ही नहीं कर रहा विजुअलाइज।
इनफेक्ट कर रहा है।
हाँ ऊपर का मैंने मतलब डाउनलोड हो गया है ना वो स्टोरेज जहाँ से आपने केरास से डेटा लिया था।
हाँ हाँ हो तो गया है। एक्चुअली मैंने कोड इस पे लिखा ही नहीं है, मैंने उस पे लिखा था जुपिटर नोटबुक में, कोलैब में। कोलैब वाला कर दिया। इसमें खोलिए लिंक।
क्योंकि ये डाउनलोड होने के लिए 1 आवर लिया है और बाकी सब में डाउनलोड कर देते हैं तो स्पीड स्लो हो
हाँ
गई है।
हाँ हाँ। नहीं नहीं ये नहीं, व्हाट्सएप पे जो किया है ना। हाँ हाँ वो डायरेक्ट ओपन करिए। आपने कोलैब खोला हुआ है? मेरा ही वाला कोलैब खोला है?
नहीं
नहीं।
ये मेरा वाला कोलैब है तो है मेरे पास ऑलरेडी टेंसर फ्लो इसलिए वो डाउनलोड करना नहीं पड़ा।
अच्छा अच्छा, तो क्या हुआ, क्या दिक्कत आ रहा है? लिंक करिए अपना अकाउंट, यहाँ राइट हैंड साइड में ऊपर जाइए, इधर आपके मोबाइल फोन में व्हाट्सएप, हाँ राइट हैंड साइड ऊपर, हाँ लिंक डिवाइसेस, हाँ लिंक डिवाइस, हाँ ओके करिए, स्कैन करिए। अभी आ जाएगा, ठीक है। जाने से पहले अपना व्हाट्सएप आप बंद करके जाना, ठीक है। इंटरनेट स्पीड बहुत स्लो हो गया। लिंक ओपन करिए जो दी है। हाँ खुलता है कि नहीं? खुल रहा है। फर्स्ट वाला रन करें। इसमें क्या प्रॉब्लम आ रहा है? इसमें भी टेंसरफ्लो कहाँ रहेगा? ओहो, साइन इन करा रहा है आपके अकाउंट से, नहीं दिक्कत है, कोई बात नहीं। So okay, let it be. If the TensorFlow is not installed in your desktop, the Google Colab file is shared with you. Okay, you can directly take that file, and after this session, you can try to run that all the things in your laptops personally. Okay, so just understand the code. Importing of the libraries, that is the first step, right? Please understand the code first. You can run after all. Certain packages that you already know. The important package is TensorFlow for the deep learning. Now under the TensorFlow, we have to import the layers, because we have direct putting some hidden layers, input layer, output layer, and send their parameters. So layers we have to import input, dense for the hidden layer, leaky ReLU for the functions, dropout in order to enhance the training part, right? And what are the others? And batch normalization. Now we have to understand about the drop and batch normalization, because the rest of the things you already know. That is, what is the input layer, what is the dense one, leaky ReLU I will tell you later. Dropout. Dropout is used to stabilize the training process of your computer when your data set is large. In our phenomena, what happening, we have 60,000 images of MNIST. 60,000 is a very high quantity. So we have to apply the dropout. By using the dropout feature, we can prevent the overfitting task. Okay? Overfitting. When our data is so large and features is very high, then there is a chances of overfitting because we have hidden layers and weight assignment over there. So dropout means we have to select each of the weights and to their layers, means how many. So dropout means we have to stabilize the training process. The dropout value is between 0 to 1. We have to select inside my hidden layer and insert layer. This bubbles. There is a full connection, right? In normal neural network, there is a full connection. But in the dropout, in order to prevent the overfitting, we will not select all of the connections. We have to suspend some connections. Mean according to the probability, we have to cancel some features such that we can expertise in some of the features in more detail. Like if we have 100 tasks, I have to complete in a 30 minutes, scenario number 1. Now we have 100 tasks, I have to complete in 2 months. In which task I have to analysis more? Second one. Same thing is with neural network. So that's why dropout. So dropout layer, suppose my probability is 0.5. So 0.5 means available connection, suppose 4. We have to select half of the connections. Half of the features I have to explore. So on, so on, so on. So each of the drop layers, suppose 0.5, here 0.5, that among of 3, we have to extend for the higher value, so 2 I have to select. Now the batch normalization, because our data set is large. So we have to train the process in terms of batch sizes. Okay, batch size we have to take. But batch normalization means, suppose if we have an intake of 600 students in computer science, right? So we have to make the sections A, B, C, D, E, right? A have 100, 100, 100, 100 and 6 sections. Now, all the sections have the same subject, first year of computer programming, suppose, right? Section A is taught by this sir. Section B is taught by me, section C is by them, and so many. All of the sections at the last have some CPGA score, average, right? And we have to provide some grading. So what is our task? We have to normalize the thing in a Gaussian curve for all of the sections, right? तभी तो grading सबकी साथ में होती है. एक सेक्शन की अलग ग्रेडिंग होगी, दूसरे सेक्शन की अलग ग्रेडिंग होगी, then there is a no normalization. In order to provide the normalization, we have to achieve the mean, variance, standard deviation same for all of the sections. Same thing is happen over there. Our data set is large, 60,000 images. We have to provide the batches, and for the each batch during the training and testing purposes, we have to maintain our mean and variance, also the momentum. Now some optimizer like gradient descent optimizer and Adam optimizer. Second line. Some of the breast cancer data set is important from the sklearn library, right? Here the data set is loaded from the keras. So means in the TensorFlow for the deep learning perspective, some of the data set is publicly available. So it is a MNIST data set. Now, SVM में हमने क्या किया था? When there is a species classification task, we have to label our data set, right? like petal length, sepal length, like so on. Like the same way, we are categorize our data set into 4 labeled: X train, Y train, X test, Y test. So loading, and from after the loading, just X train, Y train, X test and Y test, it will automatically comes. Scale the inputs in the range of -1 to +1. Why? Because we have an image in 3 dimension RGB colors, right? 0 to 255 is a very big value in order to scan that. So we have to classify in our smaller values like -1 to +1. The another option is you can categorize as 0 to 1 also. It's up to you. In my case, it is -1 to +1 normalization. So due to this scaling normalization, I have X train and X test, and I am using this formula in order to calculate all of the pixel values in terms of -1 and +1 for the better training. Because if you are training your model by using the large values like 0 to 255, then it can be chance of not analyze a feature in more detail, right? Because 0 to 255 is a large range, but here -1 to +1 is small range. That's why. Now downloading the data set by using the Keras. Some optional plots over there. In this subplot, 7 cross 7 means 7 rows and 7 columns will be appended, and I for the iteration. So I am show is for showing of the images, just like it is showing the images. After showing the images, we have to pre-process our data, because in the CNN model we have to flatten the dimension, right? For the image data, we have to flatten the dimension in one column. So same thing we have to do again. So for the dimension, we have 3 variables. N is the number, height and width. Now we have to train our X train with this shape. Now D is a dimension, is nothing but I am taking about one dimension only. Now there is a drawback of our GAN architecture. You can do further research over there. The GAN architecture drawback is it will not work over the dimension above 1. If you have a 2-dimension images, 3-dimension, 4D, 6D, it will not work. It will cover only the 1 dimension. That is the problem. There is some research is going on in which there is a transformation from 1D to 3D images or 2D to 3D images, but it is currently going on only. So there is a scope. So now the dimension, height and width. As I told you, what is the dimension? 28 cross 28. So I have to multiply, and this is the dimension in 1D. Now reshape for the flattening of images. So the first dimension will be -1 means no, there is no dimension means no row, only the column. Column in terms of dimension, that is 28 cross 28. Yes, I told you that instead of -1 to +1, you can take 0 to 1 also. Yes, you can change. Now the generator function. I am not compiling our model, I am just described our generator function. Latent dimension means the first sample space is 100. Definition function, build generator, latent dimension I am passing, that is 100 only. Now I input, how many images I am taking? 100. Okay, 100 sample from the noise. So that's why the shape is latent dimension. Input, that is the first layer of my neural network. Then these are the hidden layer, dense, hidden layer. 256 features over the activation, leaky ReLU. Why I am taking leaky ReLU? What is ReLU? 0 to 1. Okay. So actually ReLU will provide the result in terms of 0 and 1, right? But we have to take certain inputs always from the discriminator, right? As I told you, we have a joint probability 0.2 and 0.8 something. So whenever there is a positive result, then it is okay. If it is a negative result, then instead of providing the 0, I am taking leaky ReLU as alpha of 0.2. So means for each negative value, my negative value will be multiplied with 0.2, and to convert it into the positive ones, you can take 0.5 also. Convert into the positive ones and feed it in order to enhance the training process. So that's why we are stick over the leaky ReLU, not ReLU. Batch normalization and the momentum is 0.7. So this momentum is depends upon the data set quantity. My data set is large. So that's why I have to take the momentum quantity from 0.5 to 0.9. Otherwise the momentum can be 0 to 0.5 as 0.6 to 0.9. What is the momentum over there? For each batch, it might be possible that your mean can vary. Section A can take an average of 60 marks. Suppose section B can take an average of 90 marks. Large difference. So there should be momentum over there. That at which side the section A class will have to move towards the 90 marks or a below momentum. Okay. So my momentum is 0.7, means high momentum can be possible because I have applied the dropout. If some of the topics are skipped for the section A and some of the topics are completed in section B, it might be a possible that according to my examination pattern, there is a big variance in mean. That's why high momentum I am taking 0.7. So for each hidden layer, batch normalization I have to do. Okay. So how many layers? 1, 2 and 3 and 4. 4 hidden layers. But this one is not the hidden layer, this one is the output layer. So 3 hidden layers, 1 input, 3 hidden and 1 output. Here is a dimension D. Dimension D for 28 cross 28. Activation is 10 NH because I have producing my image pixel is -1 to +1. That's why. Now model equal to model IX. I is the input and X is the output layer. So my model is complete. I can take model dot predict in order to predict something from the generator images. कर रहे थे ना हम एसवीएम और नेब आइस में भी मॉडल डॉट प्रिडिक्ट, वैसे हम यहाँ पे भी कर सकते हैं. सो दिस इज द जनरेटर फंक्शन. सेम थिंग आई हैव टू डू फॉर द डिस्क्रिमिनेटर. फॉर द डिस्क्रिमिनेटर आई हैव टू पास माय ओरिजिनल इमेजेस. ठीक है. So for the original images, I have to pass the image size. So let's take the image size. You can see in this line, build and compile the discriminator. So discriminator equal to build discriminator above function, and inside I am passing D as a parameter, that is the dimension, 1D dimension. That is nothing but my image size. Now go to our files. So image size is nothing but my D. First input layer according to the dimension. First hidden layer, second hidden layer, second hidden, this is the output one. Here I am taking the sigmoid. Why sigmoid? Because I have to do the classification in terms of real and fake. Again leaky ReLU with alpha of 0.2. Reason you know. Model is ready and return the model. Now build and compile the discriminator. I have only defined the functions. अभी compile नहीं किया है. अब मैं compile करूंगी. Now I am going to compile. So for the compile discriminator dot compile. What is a discriminator? That is a function return parameter. What is a return parameter? Model itself. Return model किया था ना? Here return model by the function. This written model is a parameter which is stored by this discriminator and discriminator dot compile. For the prediction, discriminator dot predict. For the generator, generator dot compile, generator dot predict. Clear? Now the discriminator dot compile, the loss is binary cross entropy. So the same loss I am talking about, minimization and the maximization function. So binary cross entropy. Optimization, I am taking Adam optimization. So this 0.002 is my learning rate. Okay, who is fixed this learning rate? By default, it is 0.002. So I'm using the by default parameter. If your model is slow learner, then you have to increase your learning rate according to your features. Now 0.5, that is nothing but your weight updation parameter, that is the gradient. Gradient का बात किया था ना हमने, gradient used to update the weight parameters. So that is nothing but 0.5. Matrices is accuracy. I have to calculate the accuracy. So now my discriminator will going to compile after running this code. Further, I have to run and compile my generator. For the generator, same thing I am doing. From the build generator return model, and I am storing this into the generator. What is a sample? Sample is nothing but my latent dimension, that is 100. For the above case, that is D, that is the dimension of original image. Now Z, what is a Z? Noise, right? Z is noise. Z equal to input shape equal to latent dimension. Latent dimension is 100. So about the 100 images, I have to put my noise. First 100 samples. Pass noise through a generator to get an image. Pass noise. So whatever the image of 100, I have to pass inside the generator. Generator is already built. First हमने क्या पास किया था उसमें? Latent space. अभी हम Z पास कर रहे हैं. Over apply the noise, my sample images and pass, and my image will be generated. First sample will be created. Once the sampling is done by the generator, during that date, discriminator will be in halt position. So one time only one neural network will do work, not in the parallel mode. When the generator is going to work, discriminator will going in the halt position, and vice versa. Fake prediction discriminator image. So once the generator is producing you the fake images, I have to pass this fake image, IMG, noisy image, as a parameter. Now what the discriminator loss function? Sigmoid. Sigmoid. Sigmoid is able to classify your data in real and fake. So that is nothing but fake prediction. So that is for the first sample only. This is only the code. I have to provide the data after that. ये है कि जब हम डेटा प्रोवाइड करेंगे तो ऐसे काम करेगा. अभी मुझे डेटा देना है इसमें. हाँ. एक्चुअली डी आपने जो इमेज दिया था ऊपर पता है. डी इमेज दिया था वो फिर आपने फिल्टर किया होगा. फिल्टर मतलब फिल्टर मतलब उसके फीचर्स वगैरह जो एक्सट्रैक्ट किए होंगे उसको प्रॉपर एक -1 में हमने जैसे उसके फीचर्स लाए तो फिर वो एज अ डी क्यों लिया? क्योंकि वो डायमेंशन है ना. अच्छा. CNN में मुझे डायमेंशन को रिड्यूस करना पड़ता है ना. किसमें? कौन सी लेयर में? फ्लैटनिंग में. वही किया है. नाउ कंबाइन करना है हमें दोनों मॉडल को. अब हमें कंबाइन करना है. कंबाइन इन द सेंस sample images generated by the generator going towards the discriminator. Discriminator is predicting and back propagation. That is a combined model. So I'm combined model generator model my noise and fake prediction given by the discriminator. First one. Second, again compile with a loss by binary cross entropy for the discriminator. So क्या कर रहे हैं? Generator generating the images and discriminator predicting by using the binary cross entropy combined. So dot combine. पहले अलग अलग फंक्शंस डिफाइन किए, देन उनको बाद में कंबाइन किया. सो दैट इज द कंबाइंड मॉडल. इसमें किसी को डाउट है?
ये दोनों मॉडल कंबाइन करने की मतलब क्या है? ऐसा कोई सेपरेट मॉडल नहीं है जो हम डायरेक्टली यूज कर सकते हैं, ऐसा कोई है?
क्योंकि इसमें तो कंबाइन करना ही पड़ेगा ना.
नहीं तो ऐसा
कंबाइन किए बिना कैसे चलेगा? Because discriminator and generative are competitor to each others na. They are learning from each others. So the sequence is generator generating the images by using the model and the parameter is noise and the fake prediction. ठीक है? Now whatever the combined model generation parameters, I have to compile with the binary cross entropy in order to predict the losses. Sequence है ये, generation of the images and prediction. Now batch size is 32. Batch size is 32. Total images are 60,000. Batch size is 32. Epochs are 1200. My recommendation to run first time to 20,000. फर्स्ट टाइम के लिए ये मैं रन कर चुकी थी, इसलिए सेकंड टाइम पे 1200 मैंने किया है. माय रिकमेंडेशन टू रन योर कोड 20,000 इपॉक्स. ठीक है, फॉर बेटर रिजल्ट्स. सैंपल पीरियड इज 200. So as I told you, first sample is created, then again sampling will be done, and generator has to train itself with more images, and at the point when discriminator is fooled by me, then we can say my model is succeed. So you can minimize or maximize the sample period also. Once your model is making the GAN network, you can minimize the sample period as you wish. For the first time, it will get higher because your generative model is unsupervised learning. So more samples you will need to produce, right? Once used for the real one images, zeros for the duplicate or you can say fake images. Now I am storing the losses. D loss and G loss is used to plot only. Otherwise it is not needed. अगर आपको plot करना है for your research perspective that what are the losses of your neural networks, then you can use this array mechanism. ठीक है, हर epoch के लिए आपका loss आ जाएगा. Now create a file. This is also optional for the better visualization. So I'm making a directory GAN images. As I told you, after the sampling period, I'm creating so many samples. So for different epochs, I can visualize my sample generated by the generator, that it is looking to my real image or not. So that's why I am collecting for the better visualization. So GAN images is my directory. Now, in order to create the sample images, as I told you, generative modeling is my unsupervised learning approach. At the start, it is only an image with some noise, but with some hint that is pertaining to my real image is given by the user only. Because only user can tell that my noisy image should be look like cat or dog. वो तो मॉडल को नहीं पता ना, वो मुझे पता है. So that sample image coding is nothing but done by you. So I am creating the sample with number of columns 5 and 5 cross 5 के लिए. Noise, that is the formula for introducing the noise. Random noise you have to introduce from 25 to latent dimension, that is 100. So from 25 to the 100 you can select any random noise, different random noise for different sample periods. Images generator dot prediction. Generator is a model. Dot predictions, and whatever the noise you are producing in terms of latent dimension images, you have to pass over there and images will be generated. Okay, that is a sample image. Now again, you have to rescale the image, right? your image, generated image, and your real image dimension should be same for proper prediction. So again -1 to 1. So these are only in order to show the images after certain epochs. Now model function is created, model is compiled. Model is compiled, but I have to train ना, अभी मैंने training तो की नहीं है. I have to train my model. So first I have to train the discriminator and I have to train my generator model 2 times. For the first sample and for the second sample along with the feedback. ठीक है? So train the discriminator. Select a random batch of the images. You can take random also. ID. ID मुझे क्यों चाहिए? ID क्यों चाहिए? ID मुझे चाहिए because I am applying the batch normalization. I am creating batch. ठीक है? If you are creating a batch, then there is a need of enrollment number of each student in order to identify that okay 0 to 50 students are in the batch 1, from 50 to 90 in batch 2. Such like the same way I am deriving ID of the images because I have to create the batch. Otherwise duplicates ही आ जाएंगी. Real images X train ID X. So whatever the X train which is loaded from the data set according to the IT is nothing but the real images. And fake images is generated from the noise. You already know. From the noise is fed over the generator.predict and fake images. Train the discriminator. Again I am doing the training of the discriminator according to the loss. क्योंकि यहाँ पे देखो मैंने अच्छा मीटर गया यहाँ पे. फर्स्ट ट्रेनिंग हुआ था रियल इमेजेस के साथ, सेकेंड ट्रेनिंग हुआ था मेरा फेक इमेजेस के साथ. Now train the discriminator along with the real and fake. है ना, यहाँ पे लॉस कैलकुलेट हो रहा है रियल का, यहाँ पे लॉस कैलकुलेट हो रहा है फेक का, and I have to calculate the joint probability. So I have to combine both of this. Discriminator dot train on batch real image. Discriminator dot train on batch fake image. So 2 times training I have to do and calculate the losses for each and combine it because this is the joint probability of cross entropy. I think it is pretty clear to all. Train the generator, noise, combined model. एक बार मेरा जनरेटर ट्रेन हो चुका है फेक इमेजेस से, but my discriminator is ready with the real and fake images training. Now I have to take the feedback from the discriminator. In order to do that, I used combined model. Whenever I have to use the feedback, we have to use only the combined model only. So I'm using combined model, train on batch, noise, and ones. Why ones? Because I'm trying to fool the discriminator that my noisy image is real one. So that's why I am labeling all of my noisy images as ones. मैं उसे क्यों zero करूंगी? If I'm saying that my 100 rupees note is real and actually it is not real. So if I'm giving to you, I always say that it is a real note, right? सब्जी खरीदने जाते हैं जेंट्स, ज्यादातर सब्जी खरीदने जाते हैं, सब्जी वाले से पूछते हैं सब्जी ताजी है, वो बोलता है नहीं सब्जी बासी है, यही बोलता है ना सब्जी ताजी है आज ही आई है मार्केट से, वही सेम केस है, अब भी आई है. सो वही है, वो हमेशा लेबल उसको वंस देगा. First time always possibility that according to my label discriminator will predict false, means accurate result, that no your image is noisy image, it is not the real one for the first time, because in the first time discriminator did not give any feedback to the generator, right? So once it is trained, again the generator provide the same task to the discriminator again with using the same noise and ones. Same thing. By taking the feedback after training the model of itself and again giving the same image in cooperation with the feedback with the same label, that is once. Calculate the losses and sample images epoch. So now my epoch is getting run. I have to show certain images. So I'm using imread. From the imread GAN images, that directory I have used to store the sample images after sample period. So first image is 0.png. Now there are two factors. First factor is when you are running this code first time in your laptop, your 0.png image will be like something 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 and it is noise only. हाँ, जैसे इनका आ रहा है, देख सकते हैं, noisy. But in my case, I have already run my code 20,000 epochs. Again, I am doing 12,000. So model was again already trained. So that's why my images are more clear to her images. So these are the fake images. At which epoch? Epoch number 0. Sorry, starting का जो epoch है 1 epoch. So that's why 0.png is generating. Second image के लिए क्या करना है? GAN images you can convert is 1.png. That's why I am using ID. तो आप ये करके देखना. 1, 2, 3, 4, 5, 6, 7, 8, 1,000, 12,000, 20,000. 20,000 तक you can able to generate the real images. Fake images just is looking like a real image. जैसे इनका आ रहा है, इनका बहुत अच्छा आ रहा है. मेरा ऑलरेडी इपॉक रन है इसलिए वो अच्छे से दिख नहीं रहा. नॉइजी इमेज आ रही है, लास्ट में करिए. एट द लास्ट खत्म हो गया. ओके
और फिर से कर रही है. यहाँ पे 0 पे है ना.
हाँ
800 का नहीं किया.
नहीं ये भी in spite of 0 you can give how much. 1 second. हाँ 800 png write down. Yeah, you can see. हाँ और भी आप करिए, जैसे 12,000 पे करिए और क्लियर आएगा. You can see this results. This is more accurate. You can come to this computer. You can come to this computer. 12,000 इपॉक ही नहीं होगा. 0 एक हटाइए. हाँ अभी करिए. नहीं चलो छोड़ो. ओहो हाँ. So this is 0.png for the first. This is only the noise. Sir, this is only the noise. First image. 0.png. So after my epoch is running. So 12,000 ये उल्टा चल रहा है system. 800 means after 800 epochs my images will be look like somehow blur but good as compared to first one. But this is again the fake image. So if you are running your code up to the 20,000 epoch, you can visualize that you can able to generate the fake images just like the real image. Okay, understood? Okay. Now the research perspective 1 point. as we can see, for the research perspective, we have some model, right? But we need data sets in terms of image. We have to find out the data set with some open libraries, okay? Or open, or what is the repositories you have to fetch. So sometimes when the data set is not available, we have to switch our research area to some another area, topic basically, right? So you can use this GAN in order to generate some images. Like some training images you have to give for the smart, and you can generate up to 1,000 and so many, like lakhs of images, which is fake. Nowadays the research is going on in the medical field. What they will do, the medical data set is very few, okay, in terms of images. So whatever the few medical images they have, they can use that images and generate the fake images only. By using the fake images, they can pursue their research work. They can enhance the feature extraction, model selection, as well as some more accuracy in terms of application implementation. So you can use this GAN in order to generate the data, but in terms of image. Same thing you can apply to the cloning of audio files. बट ऑडियो के लिए मेरी वेव फाइल लगती है, WAVE, ठीक, उसकी प्रोसेसिंग अलग से होगी, उसके लिए CNN नहीं लगेगा. मे बी यू कैन अप्लाई द CNN बाय ट्रांसफॉर्मिंग योर वेव सिग्नल्स इनटू द स्पेक्ट्रोग्राम्स. ठीक है. सेकेंड ड्रॉबैक ऑफ दिस वन इज it is only applicable for the one dimension. ठीक है. So you can rotate your image in 3 dimensions, right, by enhancing the dimensions. So that is another research scope. So first one is creation of the database in order to pursue your research work. Second one is enhancing the dimensions. So in this area you can work. So PPT is with you, code is with you, you can visualize. There is one simple assignment to you guys. Assignment is you can take the celebrity data set from the open repository, right? Celebrity का data set मिल जाएगा, celebrity images का, ठीक है. That is real data set. Now, instead of taking the unsupervised learning approach by using the noise Z, you can use your image over there. Okay. Now your task is you have to transform your image to one of the celebrity image. ये कर सकते हैं, बहुत सिंपल है. फर्स्ट में जहां पे आपकी नॉइज से आप लेटेंट स्पेस पे जा रहे हो ना, वहां पे आप अपना इमेज डाल देना, अपने इमेज को एक्सट्रैक्ट करना. सो आप देखोगे हर इपॉक पे हाउ योर फेस इज गोइंग टू चेंज टू द सेलिब्रिटी फेस. ठीक है, ये कर सकते हैं. हो गया सर. हाँ हाँ,